Before moving on to building the web interface for microposts, there are a couple of refinements I'd like to add to the model. These are exactly the sort of details that we punted on before, but now it's important to include them. One of the defining features of a list of microposts is that they come out in a specific order. In particular, they come out most recent first. But by default, this @user.microposts does not guarantee any order. In fact, it might be the right order, but we shouldn't rely on that fact. So let's set a test for what we want this to be. Say order should be most recent first, and then let's plan to make a fixture micropost called most recent. So let's do this, assert equal and this requires adding some fixtures for the microposts. We'll add a few while we're at it. Note that I'm putting the created at column in by hand here. This is what allows us to control the order. Ordinarily, you can't set the created at column, but inside fixtures you can. So let's say that this first one, this orange, was created 10 minutes ago. And then one of my favorite status updates, this is the town manifesto. A little bit of anti-pi propaganda. And I created that actually 3 years ago or so. And this is one of my favorite cat videos. Of course, ordinarily I would just paste that URL in. Here we go. Let's say it was created 2 hours ago, and then this is the one we want, most recent. This is our status update. Our micropost here is we're writing a short test. Let's say that was created at now. So by virtue of setting these created at values explicitly, we've guaranteed that this will be the most recent. So we can save that. This might actually pass. Let's take a look. No, it fails, so that's good. It's really nice to be able to get to red. It's really hard to arrange this unless you actually manipulate this created at column. So which one came out first? Yeah, so you can see the sad cats came out first. That's kind of weird. Who knew? So this is great. We've got a red test. Now we're ready to define the standard order. The way we're going to do this is with what's called a scope. Scope is actually a fairly general concept, but the only thing we'll need is something called default scope. Let's put it right after the belongs to user. Now the argument of the default scope is a procedure that tells Rails how to order it. So the way to do that is to use this strange looking arrow syntax. Let me show you how that works. This is what's called a proc, spelled like that if you want to Google it. So let's give this proc a block that just prints out foo. You can see that returns a proc here. This is essentially an anonymous function. It's a function that doesn't have a name, but we can call it like this, .call. So the argument here is going to be order. Well, let's look at the default, the easiest way to do the order. Ordinarily, you could just give it a symbol like this, order created at. Let's go back here. You may think, well, this is the right order, right? We want the order in which they were created, but no, that's still red. And this is because order by created at actually returns the one that was created longest ago first, but we want the most recent one. So the default order here is created at ascending, but what we actually want is created at descending. This requires pushing down to little raw SQL. It's created at descending. It's actually case insensitive, but the convention is to put SQL keywords in all caps. Let's save that and see if it works. Great. By the way, I mentioned this stuff about procs. This is pretty advanced stuff, so if this is confusing, don't worry about it. Just know that when you define a scope like this, you need to put inside this block, after the arrow, a method that specifies the behavior of the scope. In this case, ordering created at descending, which, as we've just seen with the passing test, returns most recent first. Now, I've just learned from an alert Rails tutorial reader that as of Rails 4, we can actually replace this raw SQL with pure Ruby using a key value pair. So we can do created at colon and then make this a symbol. So this has the same effect. It's still nice to see that we can use raw SQL, but I definitely prefer to use pure Ruby if possible. So let's save that and see if we're still green. There we go. So there will be a little switch back to the old version because this is a quick insert into the screencasts. But this is definitely the syntax I recommend using. The second refinement we're going to implement is to destroy microposts associated with any users that are destroyed. Remember that admins can destroy users, so it makes sense to destroy the associated microposts. Let's take a look at that here. In this case, the application code is really simple, so I'm going to implement it first and then write a test. So the way to do it is just to add this one little bit to has many microposts. We say dependent destroy. Save that. Should still be green. Now let's write a test. This is on the user model now. So we can say that the associated micropost should be destroyed. That requires associating a micropost with the user defined in setup. It's this here. And remember, this is just created in memory, so first we need to save it to the database. Then we can create an associated micropost and destroy the user and make sure that that changes the micropost count by 1. So let's do that. We can create this through the association. And I'd like to use create bang in this context just to raise an error in case anything goes wrong. And then we can use our assert difference assertion. Micropost.count by -1. And then at user.destroy. Save that and see if we're red. Oh no, we should be green, right? Yeah. So now we can test that by this. Go red and green. Great. We're not quite done with the micropost data model. We'll be adding a couple more things when we talk about uploading images later in this lesson, but for now this is a great start, and certainly enough to let us move on to building the web interface for creating, showing, and destroying microposts.